This session, we are going to discuss a few problems which is based on center of gravity and moment of inertia. This is the fourth problem. Myself, P Patil, Assistant Professor, Department of Civil Engineering, Walchand Institute of Technology, Solapur. These are the learning outcomes. At the end of this particular session, student will able to learn or determine the center of gravity and the moment of inertia, calculate the moment of inertia, the centroidal axis, x axis of the plane area as shown in figure. Means you have to calculate the moment of inertia about x axis. The vertical dimension is 300 mm. Now the radius 150 mm. This is 45 degree. So one is ABD, this is your triangle, BCD, this is the semicircle, two figures they have mentioned. I am considering this is my figure number 1, this is my figure number 2. So this is the G2, and here you may consider this is nothing but your G1 is there. First of all, you may calculate the area. Area of figure number 1, that is A1. Triangle. Area of the triangle 1/2. So your base is 300, the height is 300. So you will get the area 4500 mm square. Please observe, this is 300, this is also 300 because radius is 150. Now simultaneously you may calculate the area of second figure. Area of your second figure. Area of second figure, this is A2. Area of semicircle. How to calculate it? So very simple step, pi r square by 2. Pi into r is 150 square by 2. You will get area of semicircle, that is 35342.91 mm square. This is the area of your semicircle, figure number 2 is there. Now the area is over, you may move towards the centroidal distances. How to calculate the centroidal distances? So for that I am considering this is the reference axis. From the reference axis, this is my y1 and this is up to here. This is nothing but y2 is there. How to calculate the centroidal distances? So please observe. To calculate the centroidal distances, this is y1. y1 is equal to, now you may observe here, so this is the triangle, and for this particular triangle you may consider base and toe. From base always the distance is 1/3 of the span, from toe the distance is 2/3 of the span. 2/3 of the span is now vertical 300. 2/3 of the span, this is you will get 200 mm. Simultaneously you may calculate y2. How to calculate the y2? So from here to the base, means from here to this particular, this distance is nothing but 4r upon 3 pi. 4r upon 3 pi. This is from G2 to the base BD is there. So the total distance we are calculating from the top. So you may consider this is your reference axis, 1 1 is the red color. So if I calculate from reference axis 1 1, this is 300 plus 4r upon 3 pi. 4r upon 3 pi. So 300 plus 4 into the radius is 150 divided by 3 pi. So we'll get the distance of the y2. This is from reference axis 1 1. You will get 363.66 mm. Centroidal distances are very important. Okay. Now you may calculate the y bar. How to calculate the y bar? Y bar is nothing but a1 y1 plus a2 y2 divided by total area, that is nothing but a1 plus a2 is there. So all the values are in front of you. Put the formulas. A1, that is 4500 into y1 200 plus a2 3534 2.9 into 363.66 divided by total area 4500 plus 35342.91. So after calculation you will get the y bar from reference axis 1 1, that is it's near about 271.98 mm. 271.98 mm. So let's see, observe here. Okay, we have calculated the y bar from reference axis 1 1. So we'll get here 271.98. Now you have calculated the area, you have calculated the centroidal distances. Now you have finished the y bar. You know the y bar. Now the next step is there. What I mentioned, find out the moment of inertia of the centroidal x-axis. That is, now your job is you may identify axis for triangle, y-axis for semicircle. How to calculate it, that y-axis? So let's see, observe. Now moment of inertia y-axis, that is total, is equal to moment of inertia y-axis 1 for triangle. Okay, this is for triangle, plus moment of inertia y-axis 2, this is for semicircle. How to calculate it? So the formula is moment of inertia of a triangle about x-axis. How to calculate it? So the formula is b d cube by 36 plus a1 h1 square. Moment of inertia for semicircle, this is the formula 0.11 r raised to power 4 plus a2 h2 square. Now h1 and h2, how to calculate it? So this is very simple. For example, your x-axis, it lies here. This is your x-axis. So from G1 to this vertical distance, and from G2 to this vertical distance. So this is nothing but your h1 and h2 is there. Okay, G2 to the reference axis x vertical distance, G1 to reference axis, this is the vertical distance, that is nothing but h1, and from top to here, this is nothing but your y bar. So how to calculate it, h1 and h2? It's very simple. See here, I am considering the h1. How to calculate the h1? So we'll put the value here, we'll identify here. Before that, you may identify the h1 and h2. So how to calculate h1? h1 is equal to, so this is your y bar from top minus y1, y bar from top minus y1, you will get the value of h1. How to calculate h2? How to calculate h2? So this is nothing but your h2. Okay, this distance is there. So how to calculate h2? y2 total distance minus y bar. y2 minus y bar from top, you will get h2. So y bar from top is already you have calculated. This is 271.98. Okay, 271.98. So you may calculate 271.98 minus y1 is 200. So you will get 71.98 mm. This is your h1. h2 y2 is already you have calculated 363.66 minus y bar from top, that is 271 point, that particular value we have considered here, 98 is there. So you will get the value of h2 is 91.68 mm. Now we know all the values. Okay, so let's see, observe here, we know all the values. So put the formula, put the contents in a formula, bd cube by 36. Now b is nothing but 300, d is nothing but 300, because regarding this triangle, so the radius 150, 300, 300. So bd cube by 36. Area already we have calculated. Already we have calculated the height. 0.11 r raised to power 4. Radius is 150. A to n, height is already known. So let's you observe this particular thing. bd cube. This is nothing but you may consider 300 into 300 cube divided by 36 into area of figure number 1, sorry, plus is there, plus 4500 into height is 71.98 square. This is first part, plus second part, this is nothing but 0.11 into 150 raised to 4 plus area of second figure, this is 35342.91 into height of second, that is nothing but 91.68 square. So after addition of these two brackets, you'll get the moment of inertia. So regarding first bracket, 458.150 10 power 6 plus 352.75 into 10 power 6. This is the moment of inertia for figure number 1 and figure number 2 is there. Now if I add all these things, you will get the moment of inertia Ixx. This is according to the given problem statement. You will get 810.90 into 10 power 6 mm raised to 4. This is the given answer. To prepare this particular video, I have referred. These are the references. Thank you.